Welcome to Papa Junk's shop. Don't have any projects going right now. Been trying to catch up on some of the outside work, getting the mowers ready, all that good stuff. Anybody that owns a home with property knows what that's all about. So thought I would just show you my I don't know, I guess you'd call it alternate energy system or whatever. It's more or less a hobby, just something fun, but it does come in useful too. I got a small pond. We have a spring here. That's the spring house. There's 3 families that get water from the spring. There's 2 submersible pumps in there, and I have a pitcher pump there just for fun. The kids love to play with that. Say my pond isn't very big and it needs de-scummed right now. But I have an overshot water wheel with a generator on it here. I'll give you a tour of that. Hopefully this little bit of a breeze isn't going to make the sound bad. This is the boy, she's really going now. This is the gating system, and I have 2 4-inch pipes right here that kind of maintain the water level. One here and one over here. You can see the water running down. And if I need to work on the water wheel, those lift out, and I can shut this gate, and then I have another gate here, which if I get, now we have, you know how it is, a week's worth of rain or something and we're getting too much water, I can pull those 2 plugs. I can open this gate and I can open this gate. And there's times when I've had to do that to keep it from overflowing. I'll pull one of these out so you can actually see what goes on. Just lift this out, like so. Out down there. And if I want to shut the water wheel off, all I gotta do is crank this gate shut. Like that. And it stops. The other side here. That wind. Kind of wanted to do it today because it's not sunny out. When it's sunny out, I can't see the viewfinder in this camera. So this is the what do you call it? Flume, maybe? I don't know. But I made this water wheel, well, 1990. It's been in here. The water wheel itself weighs about 400 pounds. Not sure if you'll be able to see or not. But those are old farm implement iron wheels, spoked wheels. This is 1/4-inch plate, which I cut out with a saber saw, quarter cable saber saw, 2 of them, and they're welded on to the outside edge of the wheel, and The shaft, I can't remember. It's over 2 inches. I started out with a smaller one and it actually broke where I had a pin through it to keep it locked on the wheel. So I had to take it back out and I went with this larger shaft, and then I don't know if you'll be able to see it, but I poured aluminum around it once I got it set up on both ends, because this was a big hollow spot, and it's never moved since. And I had here's a shot of the other side. You can see the weed eater got grass all over it. I had pillow blocks in there, and they would last about 6 months and they were shot, and I greased them too. And I was doing an auction, talking to an old timer, and there was a bucket of pillow blocks there, and he was kind of interested, and so was I. And he said, what are you going to use them for? And I was telling him, and he says, they won't last. And I said, well, yeah, I guess I found that out already. He says, make some out of hard maple. He says, they'll last good. He says that slow RPM, the ball bearings just plow the grease out of the way, and they don't get warm enough to melt the grease back down in. So I guess that's what the problem was. So I made some wooden ones, and these bearings have about 5 years on them so far. You can see it's just a hunk of wood. And I got a little well here. Once a month or so I come down and dribble a little oil in there. Put the cover back on to keep the water out. This design for this water wheel I got from a Popular Mechanics book. And it's time to clean all this off. This hasn't been cleaned off since last fall. And I got stainless steel edge along here. And this is PVC sewer and drain pipe, which I built a form for, and I slid it down the middle on a table saw, and I put the form in the oven and lay the PVC on it, and it would warm it up and it would form to that. You take it out and it would stay in that shape. And then there's some angle brackets here that hold it in place. And the design of the wheel, like I was saying, I got from an old Popular Science book. I think it was in the 30s. And there's quite a bit of math involved in getting the right curvature. But it holds the water all the way to the bottom before it lets it loose. So you get your maximum use of the water. And I wish my pond was up farther so I had more force, but it's right here close to the road, so you have to work with what you got. So that's as big a wheel as I can have. Back off a bit here. Better overview. So go turn that gate back on. Something kind of memorizing about that sound the water wheel makes. Go back down to the bottom and I'll show you how long that water stays in those buckets before it dumps. Getting all the way to the bottom before they dump. I'll take you inside the building and show you the generator setup. Not sure how this is going to work. Here's a look from the outside. And that is a 4-groove pulley. I think it's 44 inches in diameter, and it weighs 199 pounds. So it makes a great flywheel. Between the water wheel and that, there's 600 pounds there on those wooden bearings, believe it or not. The generator was a 3-phase, 180 cycle generator that had a Wisconsin engine on it that they used for vibrating concrete, I believe, and the engine was shot. Generator was good, but I needed it to run real slow, so I pulled all the windings out, downsized the wire size. I think I wound up with about 3 times as many turns in it, so it runs really slow. I don't know on the calendar or camera you'll be able to tell the speed or not. I think the water wheel runs around 12 RPM. And at one time I had another one mounted over here on this, and that's my panel. There's a voltmeter. You can see right now we're making about 16 volts, and we're making what, a little over 3 amps. So that's the water wheel. I'll go up and show you the windmill, and I got some solar panels too. I'll show you those. This is a windmill I've got just on top of my garage. It was an old wind charger, charging radio batteries, and I put 180 volt. I think it's a 1.5 horse permanent magnet motor on it. Made the tail fin a little bigger. You can see the old one is still on there. I just laid it on there with it. And the blade is one I got on eBay from Kansas Wind Power. It's got 11 blades on it. I used to make my own wooden ones, but this time I decided to go with a bought one. Be able to see it, but up there on the knoll I have one on a 40-foot tower that's almost the same thing. That one is a 5-blade. I think that one was a 24 volt. I built that tower. It's a self-supporting tower. Take a venture up on the roof, take a close-up of that one. This winter I had a slip ring failure on this one. Turn it out of the wind. Stop. Okay, that's what she looks like. See, that's the blade. They're plastic. It's supposed to be good for 125 mile an hour. I put it up there, the trees have been kind of crowding it. That's been there for almost as long. Okay, next we'll take a look at the solar panels. These I bought sometime in the 80s. I can't remember exactly when, but these were from a government project where they shine a mirror on them, and apparently they got the information they needed and disassembled it, and somebody bought the panels and resold them. And if you look close, you can see they're kind of brownish where they've been burnt by the mirrors, but they still were within spec, but they are discolored. And say I've had them since the 80s and they still work good. It takes 3 of those to make 12 volts, so there's like 4 sections, 2 here, 2 over there, and they're paralleled. And then this one, these are newer ones. These are only, they're probably 3 years old now. They're 100 watt panels. Got these from Kansas Wind too. I think they were like $100, maybe just a hair over. They had a sale on them, and so there's 400 watts worth there. Now this one I have on a tracker, and my homemade tracker is made from an antenna rotor, and it's mounted on a piece of 4-inch casing. And around the back side you can see my control wiring. It's back in this little cubby hole, and these are the wires coming down from each panel, which go into a larger, heavy, flexible one, and it goes to some number 6 underground cable. There it goes, about 60 feet down to the control panel. And what this does is, I think every hour, that comes on for 2.4 seconds and turns. And it does that, I think 10 times during the day, and then in the evening it'll return back to the east. And that just about doubled the output power of these, or the, the total accumulated power for the day by doing the tracking. So I'll take you inside and show you the control panel with the meters on. Okay, here's the control panel. It's mounted in the garage where you park the cars. Each solar panel has its, well, not each panel, but each group has its own meter. There's one for the windmill on the garage, one for the windmill on the hill, one for the water wheel, and I have an auxiliary. And then I have two inverters that run from that power that I'm generating now. And they also charge a battery bank, which has 2 sections, one which I don't use any of. It just sits there waiting for the power to go off to run a 3rd inverter. And, well, let me give you a close-up here. Okay, of course it's not sunny out at all, so there's the ones that were the government project. There's the ones on the tracker. There's the garage windmill. The top number is the voltage, and the bottom is the amperage. And there's the one up on the hill. And there's the water wheel. And that's an auxiliary which doesn't have anything coming into it. Okay, this is the one inverter that's actually operating now. It's running 12.5 volts and it's drawing 10.5 amps, and we're making 105 watts. And this inverter is not operational because the voltage isn't high enough. That one will come on when the voltage gets up to about 14.5. This one is my standby inverter. When the electric goes off, this one will come on. And it's on a separate battery bank. And my battery bank is, I don't have any controllers. I use the battery bank as a regulator. And that's down here. I have 2 sets of Edison type batteries, nickel iron. And I think they're 160 ampere hour. There's 2 sets of them. This is the front section, or the back section. I've got them on wheels so I can pull them out to water them and check everything. And this is the inverter that comes on when the power goes off, which feeds this panel here, which has a few. I guess I got 5 breakers in there that are active. There's a light out here in the garage, which runs 24/7. I got a receptacle here down below, which if the electric goes off, keeps my tracker powered. Got some lights in the hallway, receptacle with some lights in the living room, and some kitchen lights, and a receptacle in there that run off that inverter if the electric goes off. And those are the 2 inverters that make the power. Right now, this is the one that's running. This one will come on if it gets above 14.5. I got a disconnect for each one in case I need to service them. And inside the panel, this is the metering section on the door. And all those cables, this is where the stuff comes in from outside. These are all the fuses. Each one has a fuse on both sides, plus and minus. And I got a 200 amp main fuse in there. And these are the buses for the meters. I think there's 75 amp shunts, I should say, not buses. I got 2 bus bars that run down through. And these are the isolation diodes to keep the power from fading backwards. And on the panels on the tractor are on here. And I had to put a bigger heat sink on this one, and the thermostat and a fan that would blow on that one because it would get so hot you couldn't touch it. In the summertime, if it's clear out, it'll do about 20 amps. In the wintertime, when you got snow and it's cold, you can get 24, 26 amps on a clear day. Those are for the meters on the output side. AC fuses for the power coming from the inverters. That is a case of a surge protection. So that's what's in that panel. And over here, this is the solar panel tracking controller, and I wanted to keep it as least amount of electronics as I could, but I had to go with some electronic timers. I guess it is, what, 2.6 seconds. I said 2.4 earlier. And that's the return side. And say every hour, this cycles to move it. And then this is the one that runs it back in the evening. And I can manually override it in case I need to. And I tried to do it as much as I could with relays. So there's 3 double pull, double throw relays in there. And those are the timers and the outlets. And then I've got a meter here that keeps track of my total kilowatt hours that I've made. And we do have a generator too. This is the panel for that. And if we do run the generator, it automatically switches that inverter down there back off again, and then the generator feeds that panel. So there was a lot of thinking involved in this. But it's kind of fun to play with. So I guess that's about it. Of course, I got spares for everything up there. Spare inverter in case I lose one, a couple of spare timers, and meters. Oh, and this big old battery, believe it or not, that's half of a forklift battery, which I used to have on the tongue of my camper. So when we went camping, because most of the places we camped didn't have electric. But when we got the new camper, I decided not to use that. So I just, once in a while, I'll switch over to that one just to keep it up in shape. But thanks for watching, guys. If you enjoyed it, give me a thumbs up, and please subscribe.